anthraquinol back. Again we can able to do it for the oxidation and we are able to get the anthraquinol. So this is what So understand everyone? So that industrial method or commercial method of getting the hydrogen peroxide is nothing but the 2-alkyl anthraquinol we are going to take. Here we are going to take ethylation, you can take butylation, anything you can take. Now 2-ethyl anthraquinol, when it is going to be oxidized in presence of air, it is going to give rise to oxidized product anthraquinol and we are going to get H2O2. Now this regeneration of your anthraquinol can be done by using H2 with palladium catalyzed hydrogenation. We are going to get it back so that we can able to be making again one more hydrogen peroxide. This is going to be commercial industrial method where we are going to get the hydrogen peroxide. This hydrogen peroxide is going to be 1% H2O2. It is just only 1% H2O2. This 1% H2O2 is going to have the water. So now this 1% H2O2 is going to be contains water. So that is going to be concentrated and we are going to get 30% H2O2 by using vacuum distillation or you can say distillation under reduced pressure. Distillation under reduced pressure. We are going to be concentrating your hydrogen peroxide. 1% H2O2 which is obtained from this method is going to be concentrated to 30% H2O2 by using distillation under reduced pressure. And still more carefully if you are doing that same distillation under reduced pressure, still more careful distillation under reduced pressure is going to be concentrating this 30% H2O2 further to get 85% H2O2. We are able to get 85% H2O2 concentrated by making the careful distillation under reduced pressure, which is also called as vacuum distillation. By vacuum distillation, I can able to be obtaining 85% H2O2. That remaining water, 15%, can be taken out to get pure H2O2 by freezing. By freezing, we can able to take it out. Why? Because the melting point of your solid H2O2 is going to be lesser than your particular water. That's why you can able to freeze out this H2O2. By freezing, we can able to be obtaining the pure H2O2. The pure H2O2 can be obtained by freezing. So that water will be removed by freezing and that is going to be removed and we are going to get the pure form of hydrogen peroxide. Understand? So this is how we are going to be getting the hydrogen peroxide. When you are going to take this particular method is very useful commercial scale. So these are the preparations we are having from the hydrogen peroxide. And now coming to the properties. What properties we are going to have for the hydrogen peroxide? First coming to the physical properties. So what are the physical properties important for us? The physical properties when you are going to take, the color of hydrogen peroxide is going to be very important. So what is the color of hydrogen peroxide? When you are going to see, it is going to be appears like colorless. I think everyone might be seen the hydrogen peroxide in a plastic bottle we are going to use as an antiseptic whenever you are getting wounded. So that wounds are going to be get cleaned by using the H2O2 only. I think everyone has seen a plastic bottle in that the peroxide. It is going to be looking like colorless liquid. But actually the pure H2O2 is going to be physical properties. We are going to take pale blue color. Almost we are saying colorless only, but if you can clearly observe, the pure hydrogen peroxide liquid is going to be existing in pale blue color. So you are going to be assuming as colorless. Now this one is going to be miscible with water in all proportions. It is going to be miscible with water in all proportions. That's why we taken earlier 15 for 1% and 85%, 30% H2O2, that is going to be nothing but the water composition only. So it is going to be miscible with water in all the proportions, and it can also be miscible with alcohol and ether, whatever you are going to be having. The water is going to be combined with the organic solvent. All those organic solvents also can be able to be, because they can also able to form the hydrogen bond with them. So this is what we can able to say the miscibility. And when we are going to compare the H2O2 and H2O physical properties, they have given the table in NCERT, the values you can able to see over there. But broadly we can able to say all properties are more for H2O2, like boiling point, viscosity, density, whatever you are taking, it is going to be more for H2O2, but dielectric constant, what it is, dielectric constant of H2O2 is going to be lesser. Dielectric constant is going to be lesser, and the conductivity is going to be a small variation will be there. Other than that one, H2O2. Melting point also I said already. Melting point is also lesser for hydrogen peroxide. Melting point, dielectric constant, and the conductivity. So these three properties are lesser for H2O2. The remaining all properties are going to be more for hydrogen peroxide only. That's why we are supposed to remember the all physical properties except dielectric constant and melting point and the conductivity. A small variation only, conductivity, electrical conductivity. These three are going to be more for water. Other than that, remaining all are more for your hydrogen peroxide only. Understand? So this is what we are going to have the physical properties importance. And coming to the chemical properties. So when you are going to see the chemical properties of hydrogen peroxide is going to be having both acidic nature and oxidizing nature and reducing nature. The hydrogen peroxide can able to be acting as oxidizing agent as well as reducing agent in acidic medium, in basic medium, even in neutral medium also. We are having examples for acidic and basic mostly. The neutral we are having less, but it can able to be all the mediums, it can able to be acting as the oxidizing agent as well as reducing agent. We will see now the certain examples what they given in NCERT. So first one is going to be the oxidizing nature. In acidic medium. When we are going to see the oxidizing nature of your hydrogen peroxide, it is going to have the chance to give the oxygen, so it can able to act as oxidizing agent. In this oxidation, what it is going to be doing? So that's what you can see now. 2Fe2 plus is going to be in presence of an acidic medium, and it is going to be taking the hydrogen peroxide. Now the 2 plus iron is going to be called as ferrous state. Ferrous state iron is going to be get converted to ferric state. So it's nothing but oxidation, isn't it? Fe2 plus is going to be get converted to Fe3 plus, that is ferrous state of iron get converted to ferric state, and we are going to get 2H2O. So this is what is going to be happen. In presence of an acid, it can able to be acting as oxidizing agent. And if you are going to take PBS, lead sulfide is going to be oxidized by your hydrogen peroxide to PbSO4 plus 4H2O. Now here also the sulfide is going to be get converted to sulfate. S2 minus get converted to S plus 6. Fe2 plus get converted to Fe3 plus. All are going to be oxidations only. So these are the examples we can able to see in acidic medium how this oxidizing nature is going to be taking place. In basic medium, how it is going to be taking place. In basic medium, how it is going to be taking place. So in basic medium, if you are going to take, Now the Fe2 plus, the same thing, is going to be H2O2 in presence of basic medium. It is get converted to Fe3 plus 2OH minus. Same iron get converted to ferric state, but your H2O2 is becoming the OH minus in presence of basic medium. So this is what we can able to see the oxidation. Understand? So this oxidation we can able to see in case of the particular medium, that is going to be acidic medium, basic medium and acidic medium. So acidic medium, this is the way we can able to get it. In presence of basic medium, this is what we can able to see the oxidation. Understand? So even you can take Mn2 plus. So this is what we can able to see the oxidations of your particular hydrogen peroxide when we are going to take. This is how we are able to see the peroxide whenever you are going to take, that is going to be liberating that particular mediums whichever we are taken. This is the passion we can able to get it. And the next one, it is going to be the reducing nature. How this reducing nature is going to be taking. So the reducing nature when you are going to be taking, it is also going to be taking place in acidic medium as well as in basic medium. So first we will see reducing nature in acidic medium. So when we are going to take permanganate 2MnO4 minus in presence of acidic medium. So in acidic medium what you are going to get, Mn7 plus is going to be get converted to Mn2 plus. That already we know it, no? Permanganate in presence of acidic medium, Mn plus 7 converts to Mn plus 2, whereas in case of neutral medium or weak, this one Mn plus 4. That is going to be common when you are going to take. So now it is going to be get converted to Mn2 plus and we are going to get 8 H2O and 5 oxygens. So this is what we can able to see. The permanganate is going to be get converted to the Mn2 plus in presence of medium, and when we are going to take, this is going to be giving rise to the Mn2 plus and we are going to get H2O and we are going to get the oxygen liberation is going to be taking place in this particular acidic medium reduction when you are going to take. So one more example, if you are taking hypochlorous acid, HOCl plus H2O gives rise to H3O plus Cl minus and oxygen gas will be liberated. So this is what we can able to observe when we are going to take the acidic medium, the reduction will be taking place in this fashion, whereas when you are going to take basic medium, in basic medium, how it is going to be taking place, the reduction. So this reduction example you can take iodine when you are going to take, it is going to be get so in presence of basic medium, the iodine is going to be get converted to that particular iodide. So I0 is going to be get converted to I minus, and this I minus, when we are going to get iodide, the remaining is going to be liberation of H2O and O2. So this is what you can able to see when it is going to be iodine. It is the way we can able to get it. If you are taking the permanganate, this permanganate is also going to be get converted to, in presence of basic medium. So what is going to be happen? I said it is going to be get converted to Mn4 plus. So we will be getting the manganese oxide, and oxygen liberation is going to be taking place, and also we are going to get H2O. So this is what the way we can able to get the basic medium reduction is going to be taking place, and when we are going to take the acidic medium and the basic medium. So the difference if we can able to observe, so oxygen gas liberation is going to be common in all these acidic medium or basic medium. The reducing nature is going to be liberating the oxygen gas, and when we are going to take permanganate, I already said it is going to be fixed. Permanganate ion, when you are going to take in acidic medium, when you are going to take basic medium, when you are going to take neutral medium, when you are taking strong basic medium, their conversion is going to be fixed. So Mn+4 is going to be formed in presence of neutral medium or in presence of weak alkali medium. If it is strong alkali medium, Mn+7 is going to be get converted to +6. And normal acidic medium, we are going to get Mn+7 is going to be get converted to +2. So this is what the common thing we are having. And the same thing, MnO4 minus get converted to Mn2 plus, and we are going to get H2 and O2. And when we are going to take HOCl and H2O, it is going to be taking Cl minus. The hypochlorous acid is going to be having +1 oxidation state, it is going to be get converted to -1. So all these are going to be reductions. When you are going to take basic medium, iodine in presence of peroxide is going to be get converted to I minus. 0 is becoming -1. Whereas the permanganate, when we are taking the peroxide, hydrogen peroxide, we are going to get manganese oxide, which is going to have +4. +7 is getting converted to +4. So this is also going to be the reduction of manganate is permanganate to Mn2 plus. So this is what we can able to give the examples for the acidic medium oxidation, basic medium oxidation, and acidic medium reduction and basic medium reduction. And also the hydrogen peroxide is having the capability of making the strong bleaching. So actually that is the purpose we are also having the use. What is this bleaching action? It is going to be because of its oxidation. So how we are going to get bleaching? Now H2O2 is going to be get converted to H2O plus O, nascent oxygen. So this is going to be bleaching action, we can say. So the bleaching action of your hydrogen peroxide is because of oxidation, that's why it is going to be permanent. And now when you are going to take hydrogen peroxide, this hydrogen peroxide is going to be liberating H2O plus oxygen, nascent oxygen, and that is why we are able to be making this particular oxygen which is liberated is going to be making the bleaching action. So that bleaching action is going to be permanent because it is oxidation bleaching, and these are the properties we are having. And then coming to how we can able to store your hydrogen peroxide, the same problem we are going to have. So that hydrogen peroxide easily decomposes to H2O plus oxygen. So the storage of your hydrogen peroxide is always going to be in a wax lined plastic bottle. Whenever you are going to see your hydrogen peroxide bottles, they are going to be very soft. So that softness is going to be maintained not to get decomposed. Why it will be decomposed? H2O is highly sensitive, and this is going to be catalyzed by an alkali or a sunlight. So both of them should be not going to be exposed. So that's why we are going to use wax lined plastic bottle. So that is going to be giving a smooth surface where it is not able to be get decomposed. That is the one purpose, and it is going to be colorless. Like sunlight is also going to be decomposing. That's why it should be in dark. Hydrogen peroxide always should be kept in dark. So the reason for this one is it will be decomposes easily in presence of an alkali or in presence of a dust or in presence of any rough substance or any rough surface. All these are going to be decomposing your hydrogen peroxide. That's why these are supposed to be get eliminated while we are storing the hydrogen peroxide. That's why every time we are going to use wax lined plastic bottle and always it is going to be kept in dark. Even glass piece which is present inside as a dust, that is enough for making your decomposition of hydrogen peroxide. That's why always you are supposed to be making a wax lined plastic bottle, and even we can able to add urea as a preservative. So as it is able to be making the stabilizer, the urea is going to be acting as a stabilizer. So even you can use acetanilide as a stabilizer. These are all going to be preventing the oxidation decomposition. So that is the reason we can able to be making all these things. Precautions should be taken. So this is very commercially important that I already said, hydrogen peroxide. So what is the commercial important uses we are having by the hydrogen peroxide? Uses when you are going to take, I already said it is going to be used as antiseptic under the name perhydrol. It is using as a mild disinfectant. It is perhydrol is nothing but 30% H2O2, or which is going to be called as 100 volume strength. Under the name perhydrol, it is going to be used as antiseptic, and this is going to be used as bleaching agent. I already said it is going to have the bleaching action. Hair bleaching. Usually the hair is going to be bleached by using your hydrogen peroxide, and it is going to be useful for making perborate and percarbonate. So these are going to be a constituents of detergents. That's why for the preparation of perborate and percarbonate, it is going to be used. So this is the one more use what you are having from the hydrogen peroxide, and it is going to be having pollution, anti-pollutant. So this is very important to control the pollution. So the domestic pollution or industrial pollution, whatever the effluents we are going to get it, those effluents are going to be treated with your hydrogen peroxide so that they are going to get lesser pollution. So that's why anti-pollutant I am writing it here. What it means, it is going to be useful as to decrease the effluents which are coming from the industries, and we are going to get domestic wastes. All these are going to be treated with hydrogen peroxide. Because of this hydrogen peroxide, we can able to be decreasing the pollution. So that's why it is very important. And even we are able to use this one for the preparation of your tartaric acid and some medicinal value, pharmaceutical value, cephalosporin. So these are all the uses we are having with your hydrogen peroxide. Hydrogen peroxide is going to be commercially is becoming important because of all these uses we are having. So this is the reason we are going to be producing this one industrially. Okay, what are the uses I said? Antiseptic at the name of perhydrol 30%, and bleaching agent, hair bleach, it is going to be perborate, percarbonate are the constituents of detergents. This is what is going to be preparing the hydrogen peroxide is. And the anti-pollutant, that's already I said. And the last one we discussed, pharmaceuticals like cephalosporin and tartaric acid. These are the things are going to be prepared by using the hydrogen peroxide. And the important one we are having in hydrogen peroxide is going to be its structure and the strength. How the H2O2 structure is going to be. So broadly we can say it is going to have non-planar structure. All are going to be not in a plane. It's a non-planar structure, and we can say open book-like structure. The structure of H2O2 we can say is going to have open book-like structure. It's a non-planar. All are going to be not in a plane. They are not going to be planar. And if you can say the O and H, So if you're taking two leaves like this, and now I can able to be taking, this is one side of the book, this is another side of the book, so that's why it's going to be like a open book structure. And when we are going to take solid phase, gaseous phase, when we are going to take gas phase is going to have the different bond angle, and when we are going to take solid phase, it is going to have different bond angle. So when you are going to take dihedral angle, so that is hydrogen to hydrogen, the angle between the hydrogen to hydrogen. So for example, this is the angle we are going to take. If at all you are going to take this one as a book, I can able to be making. So like this I can able to be making. So now this hydrogen and this hydrogen, when you are going to take, that bond angle is going to be 90.2 degree. It is going to be 90.2 degree. If at all you are taking here the dihedral angle, it is going to be 111.5 degree. So in a gas phase, the dihedral angle is going to be 111.5 degree, and when you are going to take the same thing in solid phase, it is going to be 90.2 degree, and this angle is going to be 101.9 degree, and it is going to be 94.8 degree. So that the angles are going to be very important. They are going to be asking us whenever we are going to be get the question from the hydrogen peroxide. This is one of the important questions. So what will be the bond angle between the two hydrogens present on hydrogen peroxide in solid state? It is going to be 90.2 degree. What will be the HOO bond angle? It is going to be 101.9 degree. Whereas dihedral angle in case of the gaseous phase, it is going to be 111.5 degree, whereas HOO bond angle is going to be 94.8 degree. So these are the bond angles we are supposed to be remember. They are going to be asking in exam whenever they are going to be giving the question. Understand? So now this is what the structure which is going to be important, like open book structure, non-planar structure, anything you can able to say it. So that is the structure of your particular hydrogen peroxide. And the next one we are having is strength of hydrogen peroxide, volume strength. Already it was explained in some basic concepts of chemistry. Just I am going to give a summary of your volume strength. So for calculation based on volume strength, so what are the numericals which are there on volume strength of hydrogen peroxide? You can able to use 3% hydrogen peroxide is equal to 10 volume strength. Now this 10 volume strength is equal to 0.89 molar, which is equal to 1.78 normal, which is going to be equal to 1.78 normal. And you can able to take the gram per ml we are taking, it is going to be 91 grams of hydrogen peroxide is going to be present in 30%. So 9.1 gram is going to be present in case of 3%. That is not required. Most of the times you are going to get the questions based on your 3% hydrogen peroxide is going to be equal to 10 volume. So 0.89 molar, 1.78 normal. They are going to be asking the question, say for example, what will be the molarity of 100 volume strength H2O2? What will be the 100 volume H2O2 molarity? So based on this one, you can take these two combinations now. 10 volume is equal to 0.89 molar. 100 volume is equal to how much? How much it is going to be? 8.9 molar. Very easy. If at all they are asking normality, multiply it into 2, 17.8 normal. Isn't it? So this is how we can able to be making. So what is the meaning of 10 volume? What is the meaning of 10 volume strength? If at all you are taking from this 10 volume strength hydrogen peroxide 1 ml, it is going to give 10 ml of oxygen. It is going to be liberating 10 ml of oxygen. If I am taking 1 liter of your 10 volume strength H2O2, it is going to be liberating 10 liters of oxygen. If I am saying 100 volume here, what is the meaning of 100 volume? 1 ml of 100 volume if I am taking, it is going to be liberating 100 ml of O2. If I am taking 100 volume 1 liter H2O2, it is going to be giving 100 liters of oxygen gas. This volume is going to be indicating the volume of oxygen which is going to be liberated from that particular one. So that is what we are going to have. So 10 volume means 1 ml liberating 10 ml. So now if I am going to be asking the question 100 volume of H2O2, how much amount of oxygen gas is going to be liberating? How much it is going to be? 100 volume. If I am taking 1 liter, it is going to be liberating 100 liters of oxygen gas. Understand? So these are the things we are supposed to remember in case of volume strength calculations. So this is what we are going already have done in some basic concept chemistry. If at all any doubts you are having, you can ask me, no problem. So this is what we are going to have from the volume strength. And this is what we are having the hydrogen and its compounds. Whatever we discussed so far in the hydrogen, so this is going to be covered in the weekend exam. And also I said the biomolecules, until tomorrow what video they are going to be uploading. So already carbohydrates completed by the 3 videos, and now we are going to have amino acids and proteins. That much only you can able to complete by tomorrow video. So that's why the biomolecules when you are going to take, it is up to the proteins, like carbohydrates completely, protein and amino acids completely. So we are excluding nucleic acid, enzymes and hormones and vitamins. So these are the topics not there for the weekend exam. But you will be having all the questions related to the carbohydrates, proteins, amino acids from the biomolecules, the entire chapter of hydrogen. I already said I am going to give more priority for the biomolecule, that is more questions, and the hydrogen I am going to give lesser questions. That's why read carefully and watch the videos, whatever we uploaded and which is going to be giving you the notes you are supposed to write it. Biomolecules, NCERT they given, but I have added some more points extra. So just you can write down those points also which are going to be asked for the weekend exam. Understand? Any doubts are there, you can able to be. So tough syllabus. At home you are having very much free time. If you are utilizing it properly, then you can able to do it. I already saying it, for girls or boys, it is going to be 4 hours we are taking. Remaining 20 hours are there in your hand only. That's why you can able to utilize that 20 hours properly. Then you can able to do whatever the things you require. So don't say the time is not there. Structure of biomolecules already you might have learned in your botany. Okay then. So anything is there, just you can able to ask me on my personal WhatsApp number. I will clarify your doubts. And today it is going to be the end of hydrogen. If volume strength is required, just tomorrow I am going to explain some numericals, or you are having the doubts, you can able to ask me. I will be giving you the solution on WhatsApp. Thank you everyone.